Hey everyone, welcome back to my channel EduVibe. Today we will start with the practice questions. Yeah, we will cover the half of the unit of the momentum and impulse, which is the one dimensions, interactions in one dimensions. Today we are doing the practice question of that one half. Then on the next lesson we will move on to the next half of this unit. So let's start with this practice question. So first practice question we have here. So they mentioned over there that in the event of the emergency where a trail hook is not operational, a personnel abroad and the aircraft carrier could put a barricade, which is webbed netting that wraps around the aircraft and brings it to the stop by stretching. So here's the key word that this is a here's not any this is not a sum problem. This is more likely the theory question which we do in the maximum speed lesson. So in this, they mentioned that keyword is scratching that one aircraft is not operational well. So they put then a webbed, which is wrap around the aircraft and brings it to stop by stretching. They stretch that web and they stop. So the reason we have to put the reason that netting on the back end must stretch is what. So what is the reason behind this? So when they do stretching, we will do one the question related to this in when we do the maximum speed lesson. That if there's a stretching, so it increases the time. So increases the time with they decrease the force of this because aircraft is not operational. So that's why they do this to put a stretching on this to minimize the force of this. So basically, like what are doing with the stretching, with main point which is stretching. So they're doing that they increase the time of the collision. Decreases the time of the collision between the craft, between the aircraft, and the barricade. So that's how they increase the time. So we know that if they increase the time, so the net force, they decrease that net force. They're decreasing the net force experienced by the aircraft. So that point you have to know. The reasoning for this question is this, that because of this will happen. So for this follow-up question, the same situation we have, but we have now a sum for this, the proper sum. So they mentioned that the mass of the SC3 week in is 1.75 Newton per 4 kg and it hits the barricade with a velocity of 260 km per hour west. Determine the impulse experienced by the aircraft when it is brought to rest due to the barricade. It brought to rest. So this means our Vf is goes to 0 meter per second. And this is the velocity of the aircraft when it's moving. So this is our Vi, which is 260 kilometers per hour. So it goes over west, opposite direction for east. East is positive, so west is negative. So take this as negative, but this also 1000 divided by 3600. From where you get about 72.2 meter per second. Should be negative. Now you have a mass, so you know that delta P, which is the impulse change in momentum, is equal to mass delta V. Delta V is Vf minus Vi. So this you have to find. You have a mass and your Vf is 0, negative again because of Vi 72.2. So when you calculate this, when you multiply this, you get about 1.26 into 10 raised to power 6 kg dot meter per second. You get this in positive, so this is east. Our east direction is positive. So this is your change in momentum for this. which is in east. So that's how you can calculate the change in impulse. So in the one question, you get the theory question first, and you can get the sum for this to calculate the change in per impulse. Next question we have from force time graph. So we did the force time graph, and why we do the force time graph to calculate the impulse. So in this question is basically our need is to find the impulse, which they mention over there. But let's start from the question that mentioned that 2.0 kg stone is sliding on to the right on the frictionless horizontal surface of 5.0 meter per second when it is suddenly struck by a large object that exerts a large horizontal force on it for a short period of time as seen in the force time graph. So this seen on the force time graph that 2.0 kg stone is sliding from the right. So this sliding from the right somewhere, and we have to calculate the magnitude of the impulse exerted by the force on the stone, and then we have justified the Stokes setting and direction for this. So let's deal with the A part first. In A part, basically what we have to find. So basically we have to find the change in impulse. Yeah. So change in impulse is calculated by this thing. So we have to find the change in impulse for A part. We have to find change in impulse. So for change in impulse, we have to calculate the area which we have given. So for area, we have a scale over there. So it's length into width or length into breadth, you can say. So what is change in this? So length is our this one. This is our length up to there. And this is our width. So for length, it goes from 0 to 2.50. Minus, which is 2.50 minus 0, we get 2.50 kilonewtons. But main thing like that, we have to be newtons. So that kilo is 10 raised to power 3. So it comes to newton now. So you can do 2.50 into 10 raised to power 3 newtons. So this is your length. And for width, we have 15.0 over there and 16.0 over there. So you can subtract for this, like 16.0 minus 15.0, you get 1.0, which is again this is in meters. So meters means 10 raised to power minus 3. You have found this on your data sheet where they mentioned some prefix. So this is 10 raised to minus 3. So it's 10 raised to minus 3 seconds. So let's put over there, we have length of 2.50 into 10 raised to power 3 newtons multiplied by width of 1.0 into 10 raised to power minus 3 seconds. So when you calculate your change in impulse for this area will give you the change in impulse. You get about 2.5 Newton per second. You need to 2 set this, not 3. So you get about 2.50 Newton per second. So this is a change in impulse which you have to find for this one. So for B part, just after the force stops acting, determine the magnitude and the direction of the stone's velocity if the force acts to the left and to the right. So what this means to the left and to the right. So you have to find the final velocity when it just stops. It just stops. So you have to find the final velocity in both cases. But in first case, if the force is acted to the left, if it force acts to left, so you have to take this change in impulse in negative first. And when it to the right, you take this change in momentum in the positive and then find this. This type of question you have to deal like you have B. So you have mass of 2.00 kgs. You have VI of 5.0 meter per second. And you have to find the final one. But this B part for first, you have to the left. So you take our this change in momentum in minus. So it's minus 2.50 Newton per second. You know that this is equal to mass into delta V, which is Vf minus Vi. So you want your this final. So this final is equal to delta P upon M plus Vi. So our delta P is minus 2.50 Newton per second, mass is 2.0 kgs, and that Vi is 5.0 meter per second. And when you calculate, you get about Vf of 3.8 meter per second. This is to the left, so we left as negative, so this is right now. So this is right, 3.8. So for second part, you do same things, but then this thing you have to take this in positive now, because this is to the right now. So same formula you use, so I use directly Vf, which is delta P upon M plus Vi. So this final is equal to plus 2.50 into Newton dot second. Mass is 2.0 kgs plus Vi is 5.0 meter per second. So when you calculate, you get Vf about 6.3 meter per second, which is again right. So this is your two answers for this. And you get both as positive in this. So let's move on to the next one. So in this question, they mentioned that a cart on a non-friction air track with a mass of 0.229 kgs moves west with the speed of 0.700 meter per second. The second cart with a mass of 0.219 moves east with a 0.60 meter per second speed. Two cars collide elastically. Immediately after the collision, the 0.29 kg car moves the velocity of 2.50 meter per second west. Determine the velocity of the 0.229 kg immediately after the collision. So in that type of question, they confused you sometimes. So they mention not the this is object. They mention just that this is a 0.229 kg object and this is the 0.219 object. So they use that kg again and again to confuse you. But you have not to confuse in this. You just state some values which you have. So you have mass 1 of 0.229 kgs. You also have mass 2 of 0.219 kgs. For my Vi1 is moving as west, so you take negative of this, so it's 0.070 meter per second. For V2I, this one is moved with ease, so it is positive, is 0.06 meter per second. And after they mentioned that after the collision, so 0.219 kg with the velocity of this. So there's 0.219 kgs of Vm2. So it's V2F, which is 2.50 meter per second. This is west now, so this states as negative. And you have to find the 0.229 kg immediately after the collision. So this means you have to find V1F. And they mention over there this is elastically. So elastically means this is not the hit and stick, this is the hit and rebound collision. So you have to write that big formula, which is m1v1i plus m2v2i, which is equal to m1v1f plus m2v2f. So for m1 you have 0.229 kgs. For V1I, you have minus 0.700 meter per second plus M2 is 0.219 kgs. V2I is plus 0.600 meter per second is equal to your M1 is 0.229 kgs and you have to find V1F plus M2 is 0.219 kgs. And last, your V2F is 2.50 meter per second is a negative. So for the bed one, you just solve this part first, left hand one first, and this part first. So by solving this, you get about, for first one, you get about 0.0289 kg dot meter per second is equal to 0.229 kgs, which is V1F plus, you know, it's minus, and negative of 0.0547 kg dot meter per second. So when you do 0.0829 kg dot meter per second, and when you take this over there, this stays over there, this goes over there, and you do positive of this, which is 0.05475 multiplied by 0.229 kgs, and this is equal to V1F now. So V1F is equal to about 0.113 meter per second. This is in east direction because this is in positive. So I know this is the more calculation in this because we have more negative things, but no doubt this is like a question which you do practice more and more to get good in this. So for next one, you have the next practice question. So in this, they mentioned that the 1.0 kg ball moving right at 1.0 meter per second collides with 2.0 kg ball moving left at 3.0 meter per second. So here you have mass 1, here you have mass 2, here you have V1I, here you have V2I. This is in negative, this is in positive. After the collision, the 1.0 kg ball is moving left. So that 1.0 meter ball, which is the V1 M1, so this left, so this means this is a V1F now, which is in negative. The 2.0 ball is moving at 1.0 meter per second now. So this is now V2F for this. So identify the system if it is isolated or non-isolated. To find the isolated or non-isolated, you have to find what? To find the momentum. Isolated and non-isolated, remember that always you have to find the momentum. For the lasted and elastic collision, if they want, so you can find the kinetic energy, well, they compare to this. For this, you have to find the initial momentum, then final momentum, then have to know that both are equal or not. If the both are equal, so this is isolated. Not equal, so it's non-isolated. So first we have to find the PI, which is M1 V1I plus M2 V2I. So for PI, you have Y1 of 1.0, V1I is 1.0 meter per second, plus M2 is 2.0, and V2I is negative 3.0 now. So when you solve this, you get about minus 5 kg meter per second. And for next one, you have to find PF. So it's M1 V1F plus M2 V2F. So for this, your M1 is 1.0 and your V1F is minus 3.0 plus 2.0 and V2F is in right, so it's 1.0. And when you calculate this, you get about minus 1. So what this means, this both are not equal. So PI is not equal to PF, which means that this is the non-isolated thing. This is an non-isolated system. And here your momentum is not conserved. So these two things you have to write. If it's in MCQs, they already mention the options like this. For the B part, we have to determine the kinetic energy of the system after the collision. So we have to kinetic energy now after the collision, and we have to tell this is the which elasticity they have. They have inelastic or we have a elastic. So basically we have to find the both one ki, eki and ekf to find out what is ekf and to find out the what is. We have to find the eki first, which is half m1v1i plus half m2v2i square of both. So for EKI, you have V half, this is 1.0. Not care about the signs in this because you can scared of this, which is not affected your answer at all. This is 2.0 and we have 3.0 square. So when you calculate this, you get about 9.5 joules. For EKF, half M1V1F plus half M2V2F. Your EKF is equal to half 1.0, 3.0 square plus half. M2 is 2.0 and V2F is 1.0 square. EKF is equal to about 5.5 joules. So you get about 5.5 joules for EK, which is your answer for this they want. And the elasticity for this is, so your again EKI is not equal to EKF. So this means it is a inelastic collision. System is inelastic. So that's how you can deal with the EKI and everything. We have both covered in this question, like both things are covered, isolated, non-isolated, and lasting inelastic collision. So that type of question you have in your like exams or sometimes in diploma to that type of questions come. So last question for today's lesson, but more likely the very important question because this is again from the first time graph. So you can see that first time we deal with the second question in same lesson. So how important is this first time graph is for you? So this was like the simple one, not very complicated one, but we have to do the two steps in this. So the first time graph shows the object. So object starts from the rest and reaches the final speed of 8.75 meter per second. So after the force has been applied. So determine the mass of the object. So if we determine the mass of the object, so you know that delta P is equal to mass delta V. So you have to find that mass. So delta P upon delta V is equal to mass. You have a final over there. You have the final over there. So this means that the mass is equal to delta P upon Vf minus Vi. You have your Vf, which is 8.75 meter per second, minus Vi, they mention over there. You can see your force is from 0. So your Vi is also from 0. So they didn't mention, so it they goes from the rest. So like this. But for calculating the whole thing, you have want the delta P. So from where you find the delta P, you can find from that triangle. This triangle will give you your delta P, which is change in momentum. So to find the area for this. So to find the area, so change in momentum is equal to area of triangle. So it's half into base into height. So let's find what is the base or height is. So for the height, it goes from here to here. So it's from 100.0 to 0.0, which is 100.0. So when you do 100.0 minus 0.0, you get 100.0 newtons. So you can just write 100.0 newtons. And for h, you come from here to here. So it's again, it's like 0.900 minus 0.000. And you get 0.900, which is seconds. Solve this, you get about 45.0 Newton dot second. And when you put this over there, so it's now 45.0. And when you solve this, 8.75 minus 0 is 8.75. And when you solve, you get about 5.14 kgs. So this is your answer for this. You have on mass, so you get the mass of the object in kgs, which is 5.14 in kgs. So that's how you can deal with the force time graph if they carry about this mass. You have to firstly find the change in momentum, then the mass. So that's all for this lesson. We will do more practice questions in after we completed this unit. We do also diploma questions too, which are rapidly coming in the diplomas, which are like a diploma type questions we do. So learning made simple with EduVibe. Learn smarter, not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. And more, like in the next lesson, we will start with the second half. Second half is very, very important. So for this, please subscribe to my channel and click the bell icon so you get that notification of the latest lessons. So see you in the next lesson. Till then, stay connected with EduVibe.